Okay, this is part 2 video. We're going to do number 7 again. Here we have two parabolas. In how many places can two parabolas intersect? 0, 1, or 2. Okay. You could do elimination if you wanted, but since they're both equal to y, let's just do substitution. So I'm going to plug this in there. 2x squared minus x plus 3 equals negative 4x squared plus 3. What should I do? And I'm going to move them all to the left. Oh, thank you. So add 4x squared and subtract 3. And I get 6x squared minus x. Oh, well, this is easy. Factor out an x. So my roots are 0 and 1/6. So to find the y values, I just plug that in. So the first point will be 0, 3. That's one intersection. And I'm going to plug this one in there. So negative 4 times 1/6 squared plus 3. So that's negative 4 times 1/36 plus 3. Negative 4 times 1/36 is negative 1/9. Plus 3. So 3 would be 27/9. 27/9 minus 1 would be 26/9. So the second point is 1/6, 26/9. Now, will you guys, I want to do one that is a circle, like the one we did last time. Yeah, so it's a circle and a circle? Okay, hang on a second. Let me. Okay, so I'm going to do a couple different types. Y equals x squared plus 2. X squared plus y squared equals 4. So 40. Okay. So this is a circle and a parabola. How many times can a circle and a parabola touch? So if I have a circle and I have a parabola, so right now they don't touch at all. But if I move this, now they touch once, now they touch twice, now they touch 3 times, and it is possible for them to touch 4 times. Okay? So, what should I do here? I'll show you a couple different solution methods, but I can do substitution because I have y equals. So I'm going to stick this in here. So x squared plus 2 squared, and I'm going to subtract this over like that. Okay, so this is x squared, and then x squared plus 2 times itself. And this looks really hard. It's not as bad as you think. So that's x to the 4th. That is 2x squared. This is 2x squared. And this is 4. Wow. Forgot the minus 40. Thank you. Okay. X to the 4th. 1 plus 2 plus 2 is 5. And then 4 minus 40 is negative 36. That looks really frightening. But let's treat it like a quadratic. If it was a quadratic, are there two numbers that multiply to be 36, negative 36, and add to be 5? Positive 9 and negative 4. Everybody understand that? So what goes in front of those? X squared. Now, do any of those factor further? The second one becomes x minus 2 and x plus 2. What about the first one? It's not 3 and 3. 3i and negative 3i. So it's x minus 3i and x plus 3i. What does that mean? The roots are imaginary, which means they're not part of the solution set. So what we've done is we have graphed this equation. And that equation hits the x-axis at negative 2 and positive 2. And it has these other weird things that don't hit the x-axis. That's not the actual graph. But because this only has two roots, well, two real roots and two imaginary roots, that means that the original only has two intersection points. Okay? So we can ignore the imaginary pieces, and I know that x equals 2 and x equals negative 2. Now I just need to plug those numbers in to figure out the y values. So I stick 2 in there, and I get 4 plus 2 is 6. And I stick negative 2 in there, and I also get 6. So one intersection is 2, 6, and the other intersection is negative 2, 6. Okay? Now, don't write this down, but let me show you something. What if this equation down here was x squared minus 9 and x squared plus 4, or minus 4? Then there are 4 roots. 2, negative 2. Oh boy. I'm way off today, guys. Sorry. 3 and negative 3. And then you have to plug all of those back in to find the y values. Does everybody understand that? Okay, let's do same problem, different method. So y equals, what was it? X squared plus 2, and x squared plus y squared equals 40. How would we do elimination? So we have to align everything so that the x's and the y's are all in the same order. So I'm going to move this over. Negative x squared plus y equals 2. Now I just add vertically, and I get nothing there. Y squared plus y equals 42. So I subtract this over. Y squared plus y minus 42. That factors into x minus 6 and x plus 7. Okay. Now let's stick that in. Or sorry, y's. Y minus 6 and y plus 7. So it looks like there are two answers, right? But y is equal to x squared. So each y is actually attached to two x's. That's what this equation is saying. So when I plug, so y equals 6 or negative 7. I'm going to stick 6 in. 6 is equal to x squared plus 2. I subtract the 2. What's my next step? Take the square root, and I get x equals, not 2, plus or minus 2. How does that work? It's saying when y is 6, there are two x's that are valid. So 2 comma 6 and negative 2 comma 6, which is exactly what we got when we did it the other way. Now I plug in negative 7, so negative 7 equals x squared plus 2, and we subtract 2, and I get negative 9 equals x squared. And that can't happen, right? So there's a potential for 4 answers, but in this case, one of the y values creates imaginary x values, which means there's no intersection. What if this was positive 9? Then x would equal plus or minus 3. And the other 2 points would be 3, negative 7, and negative 3, negative 7. Okay. Kylie, was it you that had the 2 circles? So what are they? Okay. Okay. What should we do here? Any guesses? We could do substitution. And if I were to do substitution, I would move the y squared over. And then this is equal to that. So I would put all of this right here. Okay? That's one way to do it. Not the way I would do it. Anybody see a different method? I can multiply one of them by a negative and do elimination. Do we care which one becomes negative? In this case, it doesn't really matter. Let's just negate the top. So negative, negative, negative. The x's cancel. And the y squareds cancel. So I get negative 4y equals 16. So y is negative 4. Now, how many times can 2 circles intersect? They could be everywhere, right? Or 2 or 1. Is there any way to make 2 circles touch 3 or 4 times? No. So if I had 2 circles of different sizes, the only way they can intersect would be once or twice. There's no way to do 3 or 4, which is nice. So I now know that y is negative 4. So I'm going to plug negative 4 in here. You could plug it into the other one, doesn't really matter. So x squared plus 16 equals 20. Subtract 16. X squared equals 4. So x would be plus or minus 2. So my answers are 2, negative 4, and negative 2, negative 4. I think that covers every type. So we did 2 linear, we did linear quadratic, we did quadratic circle, and we did circle circle. I doubt you're going to see a linear circle. I don't think they're going to do that to you. Those can be kind of messy. Well, not really. Just use substitution. Okay. Back to... Oh, let's go this way. Number 8. Multiply matrices. I recommend rewriting this down below. And then you can draw the grid. And we end up with this 2 by 2 matrix. And then to multiply, you do 5 times 7 is 35. And then negative 10 times negative 10 is 100. So this is 135. The next one would be 5 times negative 4, which is negative 20, minus 40 is negative 60. Negative 2 times 7 is going to be negative 14, plus 90 is 76. And then negative 9 times negative 4 is 36. Oh, sorry. Negative 2 times negative 4 is 8. Minus 36 is going to be 28. Negative 28. Like that. Any questions on... Oh, did I mess up? Oh, yeah, of course. Okay, so we need a 2 by 2 matrix. So 135, negative 60, 76, and negative 28. See if I can do my math. Hey, I win! Okay, and then this is just distribution of a scalar and then adding them together. So we need to hit all of these with the 3 and all of those with the 4, and then we'll add them together. So the first one, negative 6, negative 9, negative 6, 9. And then second one is negative 4, 16, negative 12, and 16. And then you just add corresponding parts. And remember, for two matrices to be added together, they have to be exactly the same size and shape. To multiply, you have to have as many columns in the second matrix as you have rows in the first matrix. But if you do that little offset thing that I showed you, it will either work or it won't work. Then we add corresponding parts. Negative 10, 7, negative 18, and 25. Okay. Do we need to see another partial fractions? Yeah. Let's... So 2 by 2, so negative 10, 7, 25, and negative 18. Hey, I win. I don't often win. I'll do number 10 again. So I need to factor this, which is x minus 8 times x plus 8. X plus 8. So the left side needs x minus 8. The middle doesn't need anything. And the right side needs x squared minus 64. Okay? Oh, I guess before I do that, I'm sorry. So, oh no, this is not partial fractions. Do you guys want to see this one, or do you want to see the partial fractions? Okay. Is that number 1? Nope. Number 4. There we go. Okay, so I factor the bottom, x plus 6 and x plus 4. So this is equal to a over x plus 6 and b over x plus 4. So the a needs an x plus 4 and the b needs an x plus 6. So 4x plus 18 the numerator on the left, is equal to ax plus 4a plus bx plus 6b. Then I filter out all the x's, and I get 4 equals a plus b. And then I filter out all of the non-x's. 18 equals 4a plus 6b. I'm just going to do substitution. So I'm going to subtract b. A equals 4 minus b. Stick that in for a. 18 equals 16 minus 4b plus 6b. Subtract 16. 2 is equal to 2b. So b equals 1. And up here, if b is 1, then a is 3. So I can come over here and replace this with 3 and 1. So the answer is 3 over x plus 6 and plus 1 over x plus 4. All right, now, what if I had this same problem, but there was an x to the third on top? Do you remember what we did? We have to do polynomial division. So if I had the fraction 16 over 5, I would convert that into 3 plus 3 remainder 1. But nobody writes remainders that way. Instead of remainder 1, what do we say? 1/5. So I've taken the whole number portion out, and I have simplified the fractional portion. So if your degree on top is larger than your degree on bottom, you're going to do polynomial division. So you would do x squared plus 10x plus 24. And then you're going to go through and solve it all the way, and you might get something like x plus 1 remainder 7. So I take that remainder 7, actually, x plus 1 remainder x minus 3. I take that x minus 3 and I write it as a fraction over the original denominator, and then I do partial fractions on this. So the x plus 1 is still part of the answer, but the remainder is what we do partial fractions on. David, you're on your phone. Yeah, it hurt your grade, man. Okay. That's it. Then, so you would still do, so if the denominators are the same, if the degree of the top and the degree of the bottom are the same, then do polynomial division. And you might get a whole number piece and then a, whatever the partial fraction piece is, or sorry, whatever the remainder is, do partial fractions on that. Yeah, you'll probably just get a constant. So you'll get something that looks like this. You'll get a whole number plus the remainder, and then you do partial fractions on the remainder.